Okay, one more instant drill. Instant drill 13 on your page 29. Okay, it is given that P partly varies directly as Q and partly varies inversely as square root R. Okay, then express P in terms of Q and R. So now if we do the analysis, we can understand that P is the sum of two parts, one part plus another. The first one varies directly as Q, so it should be something times Q. The other part varies inversely as square root R, inverse, so it should be like something divided by square root R. Okay, so then we understood that this is only a draft. Okay, but when we really start to solve a question, then our first sentence here should be something like this. Part A, P equals to K1Q plus K2 over square root R, where this K1, K2 must not be 0. Okay, and then we can substitute the value set given by the questions to this formula to find out the value of K1 and K2 respectively. Okay, so let's substitute Q, R, and P into this formula. From the first set, we have 21 equals to 3 K1 plus K2 over square root 1. Okay? And from the second set, we have something like 13 equals to 2K1 plus K2, okay, plus K2 over square root 4. Okay? Okay, now these two formulas are not yet simplified, so we will use one step to simplify the two formulas before we get into solving the simultaneous equation. Okay, so here that implies that 21, 13 equal 3K1, 2K1 plus. So K2 over root 1, it should still be K2. K2 over root 4, it should be 1 over 2 K2. Okay, it should be 1 over 2 K2. So this will be our equation 1 and equation 2. And by simply solving them, we can get the value of K1 and K2 respectively. But if we take a look on equation 2 here, take a look at equation 2. Actually, I'm not quite satisfied with this equation 2 because it has a coefficient 1 over 2, which is not nice at all. Okay, because actually when we solve equation like this, we would like to have some integer coefficients. Okay, so 1 over 2 is a bit strange. Then how can we transform the equation so that all the coefficients and constants here will be integer? Okay, very simple. We multiply 2 to the whole formula, then the 1 over 2 will disappear. Okay, so we do something like this. We multiply 2 to the whole formula, then it will give us 26 equals to 4K1 plus K2. Okay, and originally it is 13 equals to 2K1 plus 1 over 2K2. Okay, this is the original one. Okay, but we don't need to write it down when we solve these questions. We can directly output 26 equals to 4K1 plus K2 directly. Okay, it will make our calculation more simple. Okay, so next, what we need to do is to do equation 2 minus equation 1, then the K2 can cancel each other. because when K2 minus K2, it becomes 0, then what left in the formula will only be something concerning about K1. So equation 2 minus equation 1, 26 minus 21 gives us 5. 4K1 minus 3K1 gives us 1K1. And K2 minus K2, 0, cancel out. So K1 is 5. Very simple. And then we have to find K2. Because K1 equals to 5, so we put 5 back into this place. So 21 equals to 15 plus K2. 15 plus K2 equals to 21. Then K2 obviously is 6, right? And therefore we have something like, finally, P equals to 5Q plus 6 over square root R. Okay? Part B, P equals 22, Q equals to 4. Q equals to 4. So therefore, 22 equals to 20 plus 6 over root R. And then we have 2 equals to 6 over root R. 2 root R equals to 6. Root R equals to... what happened? Root R equals to 3. And therefore R equals to 9. Okay? So that's all for instant drill 13. So up till here, I think some of you may found partial variation being a bit more difficult than direct variations, inverse variation, and joint variations that we learned before. Okay, because when solving partial variation, you must as well do solving system of linear equations, solving the simultaneous equation, like what you did in Form 2, okay? But actually, now you're Form 5, I think you're very familiar with the substitution and elimination here, okay? So try to do more practice from now on, okay, on this topic, okay? All right, it's a very long video today, so that's all for today. See you tomorrow.